All right, so again, when your variable is in the exponent, the first thing we're going to try is if we can rewrite both sides with the same base, which is what we're doing now. We have already done that when we were simplifying and solving our logs. So the first step is to write both sides with the same base. You always look at the bigger number and see if you can rewrite it as a smaller number. That way you only have to change one. Sometimes you'll actually have to change both of them. Okay. Then we set our exponents equal and we solve the remaining equation. So if I'm looking at my bases for number 1, 9 and 3, looking at the bigger base 9, can it be rewritten as a power of 3? Yes. Okay, so we're going to do that just like we've done before. Here we've got a little bit more involved as far as our exponents go. So what I'm going to do is I'm changing that 9 into 3 squared, but I'm keeping that exponent of 2x on the outside. The other side is already a base of 3, so I do not need to change that. And then because I have exponents to another exponent right here, 2 to the 2x, we're going to multiply those. So that's going to give me 3 to the 4x equals 3 to the 2x minus 2. And now that we have our same bases, we can drop the bases and just set the exponents equal and solve that remaining equation. So I'm going to set 4x equal to 2x minus 2. And then again, just solving the equation. So I'm going to subtract the 2x over. I'll run out of space up here, so I'm going to go over here. So that would leave me with 2x equals negative 2. And then we can continue to solve by dividing. And we get x equals negative 1. Look familiar because we've already done it? Okay. All right, go ahead and try 2 then. Again, we're just going to do a few of these to remember what we did before, and then we'll get into the other type of exponential equations that we can solve. So take a minute and just do this one for me, number 2. So I have 2 to the x minus 3 is equal to 32. Looking at the bigger base 32, is 32 some power of 2? Yes, it is. It's 2 to the what power? 5th. All right, so what I'm going to do is I'm going to leave the smaller one alone again because I can change the bigger one. I'm going to change that to 2 to the 5th power. Now that we have the same bases, we drop the bases, we set the exponents equal, and then we just solve this equation and we get x equals 8. Any questions? Okay. Try both of those. Okay, try 3 and 4. Remember with the fractions, we have to rewrite them as whole numbers by doing something to the exponent. You have your Rich chart right there to help you decide which numbers you're going to put powers and how to get them there. rewrite this as the same base. So I was looking at the bigger number. Okay. Is 125 a power of 5? Yeah. It's not sure what power. What is a cube be? So square is 2, right? So cube would be 3. So you can rewrite that as 1 to the third power. Okay. The other side's already 5, right? So just bring this on the side. Keep the exponent. Now that you have the same basis, what you do is kind of just drop those off and set that exponent equals the other exponent. Just the exponent. And it's all like that. All right, number 3, I have 5 to the 7 minus x equals 125. Again, starting with a larger number. Can 125 be rewritten as 5 to any power? Yes, it can be written as 5 to the what power? Third. Okay, so we're going to keep the first one the same. We're going to change that to 5 to the third. Now that we have the same bases, we drop those bases. We set the exponents equal, and we solve that equation. So to solve 7 minus x equals 3, we're going to subtract our 7 first. That's going to leave me with negative x equals negative 4. So then I just divide by negative 1, and x will equal positive 4. Now, looking at papers, it seems we may have forgotten the fraction part. For number 4, I have 1/2 and I have 16. How can I rewrite 1/2 that's not a fraction? What does that become? 2 to the... What do you do to the exponent to make it come up to the top? Make it negative. So that becomes 2 to the negative 1. Keeping that 4x out there. And since I rewrote the fraction as a power of 2, can I write 16 as a power of 2? Yes, it's 2 to the 4th power. Does that make a little bit of sense? Okay. All right, multiply the 2 exponents up here. So that's going to become 2 to the negative 4x. The other part stays the same. Now we can drop the bases. We can set those exponents equal and solve that equation. So if I have negative 4x equals 4, I'm just going to divide both sides by negative 4. And what is 4 divided by negative 4? Negative 1. Good? Okay. All right, one more of these before we switch gears a little bit. Everybody ready? Okay. All right, we'll work through this one. I'll get you started on it at least. Just write it down and then we'll talk about it. This time I got an exponent in an exponent, right? Doesn't change anything. The rules are still the same. I have 16 to the x minus 1 power, and I have 2 to the x squared power. Again, looking at the bigger number, can 16 be rewritten as a power of 2? Yeah, we just did that. Okay, so it's going to become 2 to the 4th. I'm going to leave the other side the same. Now here's where it's not different, but we just have to make sure we don't make a mistake. I have to multiply my exponents. What I mean is I have to multiply this 4 by that entire exponent there. So that 4 is going to get multiplied by both x and negative 1. So think about distributing that 4 to both of those. So that's going to become 2 to the 4x minus 4. Whoops. I keep trying to write an x and I don't know I was. Okay. So ours are good. Now I have the same bases, so I can drop my bases. I can set my exponents equal. This is going to be a little bit more complicated to solve because what are we going to have to do to solve it? Well, I can't square root because I have an x and an x squared, okay? We're going to have to factor it, right? So because anytime I have an x squared and an x term, it's going to have to be factored. But before I can factor it, I have to get it equal to 0. And the other thing with that is we want to keep our x squared positive. So to make it equal to 0, I don't want to subtract x squared over, okay, even though that would be a little less work. What I do want to do is move the 4x and the 4. So I'm going to subtract the 4x and add the 4 over to the other side. Getting those with the x squared, but keeping that x squared positive. So over here, all of that cancels out to just be 0. And then on the right side, none of those are like terms, so I'm just going to write them in order, highest exponent first. Now take a minute and finish it. Factor that. X squared minus 4x plus 4. What numbers multiply to give me 4 and also add to give me 4? 2 and 2. Okay. Setting up my 2 parentheses. I'm going to put 2 in both. Are my signs going to be the same or different? Same, and they're both going to be negative. Set each one of those parentheses equal to 0 and solve. And in this particular case, I end up to get the same answer twice, right? Okay, so that's okay. That just means that's going to be my answer. You don't have to write it twice. You can, but you don't have to. You can just put it as x equals 2. Okay, you can just write one of them. You don't have to write them both. Now, if they were 2 different values, yes, you would need to write them both. But in this case, it was the same number twice. So we feel pretty good about being able to write both sides with the same base. So sometimes you can't do that. You cannot write them as the same base because they're not numbers that are related. So there are a few different steps to solve that. How do you know when to do it? Well, you try. If they can be written as the same base, you do it like we've just done. If they can't, there's a second option. I'm going to give you a few minutes to write these steps down, and then we'll talk about how to do that. You'll also need a calculator, so if you don't have one, you're going to want to grab one. Okay, give you all right, so this time, when you have a variable in the exponent and you cannot write both sides with the same base, you're going to follow these steps. We're going to take the common log of both sides, which means I'm going to write log on both sides of the equation, and you'll see that as we start to work through one. Then we're going to use the laws of logs to solve for x to get the calculator ready for. Again, I'll explain what that means in just a minute. And then you're going to find the value of x. So on your test, you'll actually have 2 answers here. You'll have the calculator ready form, which gives you majority of the credit, and then you'll have the decimal that will give you the rest of the credit. That way, in case you enter something in the calculator wrong, you get the credit for being able to solve the problem. Does that make sense? All right. It's not working. There we go. Sorry. All right, so take a minute, write question number 6 down. These actually can be done a few different ways. I'm just going to show you the way that I think is the easiest, that leaves the least room for error. So we have 3 to the x power equals 32. How do I know I need to use this method? Is because 32 is not a power of 3. Is everybody ready? So the first step says we're going to take the common log of both sides, which means I'm literally going to just write log in front of both sides of this equation. So I'm going to change that into the log of 3 to the x power equals the log of 32. We are using the common log base 10 so that we can get to our calculator. Now to get it in calculator ready form, I need this thing to say x equals, or 2 times x equals, or 3 times x equals, or whatever's in front of x equals some stuff. So what we're going to do is we're going to use our law of logs. How can I get that x out of the exponent? What does the rule say? The exponent can go where? The properties that we talked about last week. What can I do with that x? If it's in the exponent, I can put it in the front, right? So what we can do, using our laws of logs or our rules for logs, take this exponent and move it to the front and multiply it by that log. So far, so good? Okay. Now, to get it calculator ready, I need to get x by itself. So right now it says x times the log of 3. How do I undo that? How do I undo multiplication? Divide. So what we're going to do is we're going to divide by the entire log. So that dividing both sides by the log of 3. All right, so then I end up with my calculator ready version, x equals the log of 32 divided by the log of 3. Okay, so that's your calculator ready. That's what we will leave in one of our answer blanks on our test. And then after that, you just go to your calculator. Remember when we did our change of base, when we have one log divided by another, we have to make sure we close the parenthesis. So when we go to our calculator, everybody grab your calculator. We're going to hit the log of 32. Make sure you close that parenthesis behind 32. And then we're going to divide that by the log of 3. And close that parenthesis. And then we're going to hit equal. We're going to go to 4 decimal places. Making sure you get the right thing in the calculator, we get 3.1546. Okay, so 2 different parts, calculator ready form and then decimal. Excuse me. Now, can the other ones be done this method? Absolutely. Okay. You don't. Once you learn this, you can use it for anything. Does that make a little bit of sense? All right, I want you to try the next one. Try 14 to the x power equals 283. Take a common log of both sides. Then you use your rules for logs to get that x out of the exponent. Then go to your calculator once you get your calculator ready for it. Properties to get that x out of the exponent. Then get the x by itself by doing your calculator. Again, we're going to take the log of both sides. We're going to use our rules for logs, moving that x to the front. Now getting x by itself, so I'm going to divide both sides by the log of 14. Whoops. So calculator ready is going to be log of 283 divided by the log of 14. So that's one part of my answer. And then in my calculator, to 4 decimal places, I get 2.1392. That look about right for everybody? Anybody have any questions? Got just a couple more. All right, last two. I want to show you how to leave the calculator ready here for this. If you'll take a minute, write your question. Go ahead and take your logs on both sides, and then we'll talk about different calculators. Okay, so here, this figure number can be changed to that as a power. So it can be written as a power. Right. Here, 32 is not. If you look at your power, 32 is not an option. So I can't change that. And on the test, it'll say, get it calculator ready form. So that's going to be your clue to do it this way. You can technically do these the same way. It's just, to me, it's easier to do that because you have your power. It's going to say get calculator ready, so that'll be your answer. All right, so go ahead and take your log on both sides. This one's slightly different just because I have a number with my x value, so my calculator ready is going to look a little different. All right, and then this time to move my exponent this time is a 2x, not just x. So we're going to take that 2x and we're going to move it to the front. Now I could ask you to do calculator ready a little bit more complicated than I am. I'm trying to keep it as easy as possible. So what I want you to do is, how would I get that 2x by itself? What would I need to get rid of if I wanted to keep the 2x by itself? Log of 7. So let's divide both sides by the log of 7. Because it's a little bit more difficult to enter in the calculator if I try to get that 2 away from the x as well, I'm okay with you leaving calculator ready like this. So if you have a number multiplied by x, or a number added to x, or a number subtracted to x, if you can get that by itself first, work in your calculator. So in this case, if I have 2 times x equals the log of 83 divided by the log of 7. First of all, do log of 83 divided by log of 87 in your calculator. Help if I press the right numbers. But after I do that, there's still a 2 being multiplied by x, right? So how would I undo that? I would just take this number that I have in the calculator and just divide it by 2. Okay, so we're going to leave our calculator ready like this. You're going to do log of 83 divided by log of 7, hit equals, and then one more time, just with this number in the calculator, just go ahead and hit divided by 2. And then that will be our final answer for x. So I got 1.1354. Okay, so if you have a number being multiplied by your x, your calculator ready will just leave that number with the x. Do the logs in your calculator and then divide by whatever number's next to x. If that makes sense. Makes sense? All right, try last one. Again, on the test, you'll have 2 spots, one for calculator ready and then one for your test. The calculator ready will get you the majority of the credit just in case you make a mistake in the calculator. So we're going to take the log of both sides. We're going to get that exponent away and move it to the front. We're going to get that negative x by itself by dividing by the log of 3. So my calculator ready is going to be negative x equals the log of 6 divided by the log of 3. In our calculator, we're going to do the log of 6 divided by the log of 3. And then we'll divide it by negative 1, which basically means we're just changing the sign of it, right? So we should get negative 1.6309. Is everybody okay with that? Any questions?